Okay, good evening. Welcome to this webinar on heart rate monitors. My name is David Marlin, and hopefully this is going to be entertaining for you. It's a warm day here. I've got my doors open, and one of my dogs is just wandering in. If there is any noise, I may just stop and shut the doors. I can see most people seem to be logged on. So let's make a start. So just in case you're not familiar with Zoom, just tell you a little bit about the controls. If you can see me but you can't hear, if you click this little up arrow on the left, that will take you to various audio settings where you can change excuse me, which speakers you're using, and you should be able to then change to be able to hear. We won't be using the chat or raise hand controls tonight, but we will be using the Q&A, and I prefer if we can save those to the end, because it can be very difficult to sort of keep the flow if we stop to answer questions. If you want to ask a question, you just click on that Q&A icon and you type your question into the box. And if you don't mind us all seeing who you are, you can then just press send. If you want to ask that anonymously, just tick the send anonymously box and before you press send. And that's it. There is one more thing. We will be doing some polls tonight. Try and make a little bit interactive at the start. It's very simple. You'll see a window like this pop up. You simply choose which answer, and then you click on submit down the bottom. And then we can all see the polls are anonymous. It gives everyone an idea of who's on and what sort of experience they've got. So let's start. What are we going to cover? We're going to talk about what is heart rate. I know that sounds maybe a bit silly and a bit basic, but it is worth us kind of looking at what we're talking about. We're just going to briefly talk about what controls heart rate, because that's important for understanding how you interpret the recordings you get from a heart rate monitor. We're going to look at the main factors affecting a horse's heart rate. We're going to look a little bit about how heart rate monitors work, because again, you need to really understand that to make the right choices, because some of them have lots of different features. We're going to look primarily, we're interested in heart rate and exercise, so that's what we're going to focus on. And then we're going to look at heart rate in recovery, and then I've got some traces, ones that I've collected over the years. I've got some very old ones. I've actually got some very new ones, and those give us an opportunity to kind of look at the sort of recordings you're probably likely to be getting and what sort of interpretation we can make from that. So this morning I was digging through my cupboards, and I remembered that I had this, which I rescued from a skip at the Animal Health Trust about maybe 25 years ago, and it was a shame. I thought it was being thrown out. It's a 1955 animal horse ECG machine that was presented to the Animal Health Trust by the Queen on one of her visits. And that's basically what we used to have to measure heart rate in horses. Now, things kind of developed, and this is one of the first heart rate monitors that was produced for horses. In a way, it used to be quite comical, because the person riding the horse, this didn't have any recording. It just showed you heart rates. So the person riding had to call out what the heart rates were whenever they were asked. And that was an EQB monitor that came from the States. EQB doesn't exist anymore. But a lot of the initial studies of heart rate on horses were done on this type of monitor. We started to move towards using telemetry ECG in horses. My colleague, Dr. Leslie Young, cardiologist at the Animal Health Trust, and I did quite a lot of work on exercise in ECGs in horses. And this is a human heart rate monitor ECG machine that would transmit from the transmitter here on the horse over a distance of sort of about 500, 600 meters. which made, as I say, proper exercise in real time, telemetric ECG possible in horses. And then, of course, we have what you will probably recognize as heart rate monitors. These are, this one I can't remember, bottom right. This was one I had for a while. This was a polar. This was one of the really early polars. It was called a PH200, and that was, I think, the first horse heart rate monitor that Polar actually made. And again, many studies in the scientific literature were done using those Polar PH200s. Now, I'm going to start with a poll here, and you'll see what I'm going to ask you. So the first question I want to know is, how many of you have an equine heart rate monitor? Okay, you're all very quick on the polling. That's good. It gives us more time. So we've basically got about, okay, it's about 60-40. That's interesting. Okay, so I can share the results now so that you can see those. As I said, 40% yes, 60% no. So what we're going to do, I'm going to move on to another question now. How often, if you said you had an equine heart rate monitor, how often do you use it? Okay, a real big mix there. Either those who have got them are either using them quite frequently or really not at all. So I'll split right sort of almost quite down the middle. Okay, let's have a look. I'll show you the results there. So most people who have them are using them sort of weekly. Okay, and finally, how do you use it? For training only, competing only, training and competing, or something else? I was going to get worried if there was too many something else. I'm beginning to regret not pulling the blinds tonight. As you can see, I'm bathed in sunshine. Okay, so we've got there. Most of you are using them for training only. Let's show you the results. Some of them are using training and competing. Very few of you using them for competing, or none of you actually for competing only. Okay, so this is interesting because I would be using them for training and for competing. Right, let's get rid of those and we'll move on. So what is heart rate? Well, I'm sure for many of you it's fairly obvious. It's the number of times the heart beats per minute. So if we've got one beat every 2 seconds, that's 30 beats per minute. One beat per minute, so per second, and 1 beat per minute, you'd be dead. 1 beat per second, 60 beats per minute, etc., etc. So that's what we mean when we're talking about heart rate. Now, what controls the heart rate? Well, as many of you will probably know, that if you take a heart out of the body, even if it's got no blood supply or well, for a short period of time, the heart will continue to beat. And that's because it has its own rhythm generator in the right atrium, which is called the sinoatrial node, or more commonly refer to as the pacemaker. So the pacemaker will make the heart beat at a certain rate, even if there's no other inputs coming in. But of course there are other inputs, and we have both branches of the nervous system, the sympathetic, the green, which speeds up the heart, and of course the hormone adrenaline is associated with the sympathetic nervous system. And then we have the parasympathetic, acetylcholine, that slows down the heart if that nerve is firing. So most of the time there is, or in a lot of situations, there is a little bit of a fight, if we want to call it that, between the sympathetic and the parasympathetic for who's in control. Now, when we get into exercise, once we get above about a heart rate of 150, 160, the sympathetic nervous system is completely in control. Between about 160 and maybe 100, there's a bit of a mix between the two, but then primarily at rest, it's the parasympathetic that controls what's going on. And the heart is also, as we've just mentioned, adrenaline. The adrenaline arrives to the heart in the blood, and that has an effect directly on the heart itself, and adrenaline would be speeding up. There are other things we don't need to worry about them too much, but just for completeness, the amount of blood flowing back to the heart, if the venous return, the amount of blood coming back in the veins drops, then the heart will slow. The heart rate also changes very subtly with breathing as well. So those are the main things that are controlling the heart. Now, these aren't the things we're particularly probably interested in, but the things that influence the horse's heart rate are mediated through these things here that we're talking about. So what influences a horse's heart rate as far as we're concerned? Well, the most obvious one, and the one we're going to focus on primarily tonight, is exercise. But of course, temperature is very important. If the horse has an elevated temperature, that will push the heart rate up, because the heart has to pump harder, to pump more blood around the body to the skin to help get rid of heat. The heart rate may also be higher in the case of arrhythmias, abnormal rhythm. And then the things probably that horse owners will recognize, pain, of course, will push the heart rate up. If the horse is startled or stressed, and dehydration. So if the horse is dehydrated, the heart rate will also be up. So when we are looking at a horse's heart rate in any situation, we have to be cognizant of these different factors that could be influencing the measurements that we're making. Why might we use a heart rate monitor? Well, of course, training, fitness assessment, competition strategy, analysis are the things we're going to focus on. But of course, behavior and research are quite common uses. Here's a recent behavioral study where they looked at the effect on heart rate of showing horses feed and then actually giving it to them. And this horse, interestingly, this is a single horse over sort of about a 20-minute period. You can see that when the feed was given, there was about a 20 beat per minute increase in heart rate. But actually, interestingly, when the horse was shown the feed, it didn't react. Transport research has been another sort of big use of heart rate monitors and ECGs. I did quite a lot of this work back in sort of late 1990s, where we were looking at the heart rates of horses during traveling. And you can see this is one horse on 2 occasions. The first occasion, the horse's heart rate very high and then drops down. But on the second occasion, it's actually tending to be lower, but actually during the transport itself, this was the same trip both times, that the heart rate's actually high. Now, these aren't massive heart rates most of the time, but it does indicate that there's some influence of transport on the horse. And in fact, we can see that generally the times when we get the higher heart rates are either, this is when the horse was being walked before being loaded. On the first day, it was quite excited, not so much on the second. Heart rates during loading, not particularly high, but interestingly, on the first day when the horse was unloaded, heart rates much higher than on the second day. And we can look at different horses and we can see quite easily that differences between them. These are on the same scale, 20 to 160. On the left, we've got a relatively relaxed horse. The heart rate's sitting most of the time during transport at about sort of 30 beats per minute. This one here, setting a little bit higher, but look at all these spikes as the horse reacts to things like noise or braking or cornering. So let's come back to what we're going to focus on primarily, and that is training, fitness assessment, competition strategy, and analysis. So what should a horse's heart rate be? That depends what it's doing. Now, it's very hard to be exactly prescriptive because many factors such as age, fitness, health, breed, genetics will influence what a horse's heart rate are going to be. But generally speaking, you know, if we've got a horse standing in front of us, perhaps a heart rate of around 30 to 40, if we were taking that with a stethoscope or holding a heart rate monitor on. Interestingly, if we put a recording system on and walk away from that horse and leave it quietly, we might see the heart rate drop into as low as 15 to 20 beats per minute. And also the horse drop in beats, which is called second degree AV block. Perfectly normal, happens in very fit human athletes as well. But you can see that as we go up in speed here, we're going up in heart rate. And when a horse is at gallop, the heart rate is going to be somewhere between about 190, maybe 230, 240 beats per minute. And we can sort of characterize this into low intensity, medium intensity, and high intensity. Why is this important? If we do low intensity work during early training, that's beneficial. That's, that's our long, slow work preparation. That's great. The horse is going to respond to that. If we do long periods of medium intensity work, we're going to tend to build aerobic fitness. If we do a lot of high intensity work, we're going to probably build speed at the expense of stamina. So we don't want to be training up here to be an endurance horse, and we don't want to be training down here to be a racehorse. So knowing where we should be training is important for what we want from our horse. Now, this is the best analogy I think I found about what the heart rate is really telling us in a horse. So if you think in your car, you have a speedometer, and the speedometer tells us how fast the car is going. But you also have something else which probably most of us don't take any notice of, and that is what's called a rev counter. And the rev counter tells us how hard the engine is having to work to drive the car at that speed. So I think you can probably now guess where we're going to go with this. The equivalent in the horse is the heart. We can call this the engine. Okay, you might argue the muscles of the engine, but the muscles and the heart is a muscle. Essentially, your heart rate monitor is your rev counter. For whatever that horse is doing, the heart rate tells us the strain on the horse. Now, that's pretty much true once we get above about 150, 160 heartbeats per minute. It can be misleading at lower heart rates because of this problem that the heart rate isn't being totally controlled by the sympathetic nervous system. And I'll come back to that. So your heart rate monitor is your horse's rev counter. Now, how hard is my horse working? Well, that's an easy question. We just put on a heart rate monitor. And how hard your horse is working is going to be a combination of how fast it's going, whether it's going uphill, on the flat, downhill. If it's on a soft surface, that's going to be pushing the heart rate up. If it's very hot, humid, still, then that's going to make the horse work harder, push the heart rate up. And the more weight the horse is carrying, the higher the heart rate. So in fact, there's lots of different factors that influence the exercise intensity and which would result in a higher heart rate. So things that would result in a low heart rate are flat or downhill exercise, the speed, low speed, short duration exercise, working on a hard surface, working in a cool environment, for example. So you can see all of these things. High intensity, high heart rate would be going uphill fast for a long time on a soft surface, hot weather. Again, you get the picture. The important one actually here that's interesting is that we may sometimes forget is a constant speed in a straight line is much easier work than changing the speed and lots of turning, because that is that pushes heart rate up. That's quite energy demanding to keep changing the speed and changing direction as well. Even if these were doing the same average speed, this would be a better strategy. And there are other factors that influence the heart rate. Age, as we said, being an athletic breed, such as a thoroughbred, perhaps versus a less athletic breed like a cob. So we covered a lot of these in the training talk. So let's move on to talking about how the heart rate monitors work. I've just picked just a few to show here. Actually, the Arionio one is the Equine is a system I've had some experience with. Same as Polar. I'm not that familiar with the high-low fit system. It was originally based on the Polar transmitters. I believe they've now switched over to their own. But understanding a little bit how the heart rate monitor works can, I think, help us understand how to use it and get the best out of it. So to explain the heart rate monitor, I'm going to go back to ECG. With an ECG, we know exactly by looking at this where the heart is beating. There is no doubt in this. This is why we say the ECG is the gold standard. Again, on here, each one of these represents a beat. I can tell that very clearly. And the human eye is often better than many computer programs in actually recognizing what is a beat and what is not a beat, especially when there's a lot of noise on the signal. Now, if we look at a human ECG, we're all probably familiar with that classic. We see it going across the screen in casualty, usually when something bad's about to happen. And the time interval between what we call these peaks here, the R wave, and the R wave is when the big vessel, the big chambers at the bottom, and we call them vessels, the big chambers at the bottom of the heart, the ventricles, when those contract, squeezing blood out, pumping blood either to the lungs or around the body, that's what we're seeing in this, what we call the QRS complex. And in fact, when we count heart rate, we're looking at the interval between these two waves. And we can calculate a rate for what this is, because if this is 1 second, if that carried on at exactly that same rate, we would have 60 beats in the minute. So that's a very easy way to understand how we count them. Now, I'm going to show you, before we ignore this, a horse ECG should look upside down to a human ECG. And that is because the horse has a different pattern of electrical activity in its heart to human. So if somebody shows you this, you know that this is the correct way up, as opposed to, it shouldn't look like a human ECG. It should look the wrong way up. Now, go back to human, because I think that's probably what most people are familiar with. So we've said every time we see this, this R wave here, this peak, we know we've got a heartbeat. And what's happening during this period is that the heart is pumping blood out. The ventricles are the big vessels at the bottom of the heart are contracting and they're squeezing blood, and blood from the right side is going to the lung, and then it's going to come back into the left side, and then it's going to go out round the body through the aorta. And then this is the period when the heart is filling with blood. So the period of contraction is actually pretty short, except of course if the heart is beating really fast during exercise. So we've said this is, if we've got a 1 second interval, that's 60 beats, and we say this is also, sometimes you'll hear it called the RR interval. Now, if we were talking about something called heart rate variability, which some heart rate monitors do offer that functionality, heart rate variability is used a lot more in research than it would be sort of in training or fitness. But if we were talking about heart rate variability, we'd be talking about this RR interval. But we're going to ignore heart rate variability. If anyone wants to ask about that at the end, you're more than welcome. So if there's a longer period, we've got a slower rate. If they're closer together, we've got a faster rate. This is all pretty straightforward. I'm sure you're all happy with this. So how does a heart rate monitor work? What a heart rate monitor does, as opposed to an ECG, is the heart rate monitor usually is averaging over, excuse me, over a period of time. And many heart rate monitors either have 5 or 10 or 15, 30, 60 seconds that they average over. Now that can help, because if you're trying to look at the monitor while you're riding, you don't want it changing every beat. You want to be able to see on average what sort of heart rate am I riding my horse at. So the problem is with heart rate monitors, they generally don't record the ECG, so you can't go back and check if they were right or not. So you have to use a system that's been properly validated, because otherwise they can give numbers, but they can be very misleading. And the heart rate monitor just really looks for these peaks here and then counts them and works out how many there are. And if we put a heart rate monitor onto a horse and it counted for 5 seconds and saw 6 beats, it would show after that period 72 beats per minute. And it would display that for the next 5 seconds until it had counted the next beats, and though there are more beats there, and it would show a higher rate. And so what it's doing is every 5 seconds is telling you what the average has been for the previous 5 seconds. Now, sometimes we might want to use 5 seconds, 15, 60, we can talk about that in a bit. There are basically 2 types of heart rate monitors. Ones that don't record and just show your heart rate, and the others that record and allow you to download to a computer afterwards and actually do some analysis. Now, obviously the ones that don't record are a lot cheaper, but they do have the limitation that you can't be that sure about what you're seeing, or what's happening, because you can get problems. For example, if you've got an electrode that's slightly loose, it can sometimes look as that's moving with the horse's stride, that might give you 120 beats per minute, which sounds about right. But actually your horse's stride is 120 beats per minute, strides per minute, and that's giving you a false signal. So it's always worth, if you are going to try and use heart rate seriously, to invest in ones that record. There is a third type, the sort of polar ones on the handle that, excuse me, you only really use when the horse is standing still. So, for example, for using as taking a recovery heart rate. Now, what we can see here is a very simple piece of work. The blue is the horse's speed. So here the horse has walked, stood, trotted, stood, slow canter, stood, faster canter, stood, stood, fast canter, stood, and then walked. Now, some interesting things we can see here. The heart rate isn't completely steady, even though the speed more or less is. And that's what we're saying, particularly at these lower speeds, we can see sort of spikes in heart rate as the horse perhaps sees something that's interesting or gets a bit keen to go. And we can also see here that even though the heart rate drops quite quickly in the first sort of minute or so, once we get back into walk, the heart rate is going up and down. And that is not driven by the effort, because the effort, as we can see here, is pretty steady. So how do we interpret this data? What we want to do is we want to be able to put a number on this that tells us something about what was happening on that day in that piece of exercise. And one of the ways we can do this is by understanding about the relationship between effort, or let's say speed, we'll just keep it simple in this case, and heart rate. So if we start at a resting heart rate of around 40 and we put the horse into trot, we should see an increase in heart rate. If we go into canter, we should see another increase. And then as we get into gallop, we start to reach a plateau, because obviously the heart rate can't keep going up forever and ever. And this is what we would say is the horse's maximum or peak heart rate. Now, the principle here is that below this point, an increase in effort is proportional to an increase in heart rate. So if the horse works twice as hard, the heart rate should go up by the same amount proportionally. So we've got maximum heart rate here. But what else can we describe about this line? What happens if we had a different horse that had a different relationship and we wanted to compare the two? Well, this is where we use two different heart rates to describe what's going on these lines. And you'll perhaps have heard some of these terms when we actually explain what we're looking at. One heart rate is around 140, one is at 200. 200 is a nice high heart rate because it's above that 160. So pretty much whatever the horse is doing is influenced by the work and not by anxiety or excitement or other things. But it's not quite at this point where it's plateauing off. And what we're interested in is at what speed did those heart rates get reached? Now, obviously, if it's a 140, that's going to be reached at a slower speed than the heart rate of 200. But what these are referred to is, and there's nothing magic about these, they're called V140 and V200, and they're not complicated. They're not complicated mathematical equations or anything. They're just a way of expressing where that line is. And what this means is that for this horse, it's V140 at a heart rate of 140, it was doing 4.2 meters per second. Or if I ride that horse around 4.2 meters per second, which is a fastest trot, I should get a heart rate of 140. Up here, I've got a V200 of 8 meters per second. That means if I ride my horse 8 meters per second, its heart rate would be 200. And this is what allows us to compare different horses. So all you need to tell me about your horse would be its V140 or its V200, because a higher V140 is a sign of either higher fitness and or higher ability. Now, if I trained my blue horse, it might end up here. But if I train my red horse, it might end up here. But it doesn't tell me anything about their fitness. It's just a snapshot in time, but it does tell me quite a bit about that horse, as we'll come on to see. Now, the only caveat here is if we are going to compare them, we would have had to have tested them either at the same time or in very similar conditions. And we'll see why that's important. So if you're in the position of wanting to compare two or more horses, my advice would be to run them together as a group. And that can be in pairs or as small groups, or as you can see here. If all horses do the same task, the same amount of absolute work, then we can directly compare how they responded to that. And we can compare their heart rates during the exercise and their recovery heart rates. And a combination of those things tells me something about their ability and also about their fitness. And in a very, very simple way. It's really not as complex as sometimes people try and make this out. My other advice is keep the test short, because the longer you go on, the greater the influence of the environmental conditions. So if you do a test under about 15 minutes, sort of a warm up of 5 to 7 minutes, and then 10 minutes or so of cantering, different increase in speeds, then that's unlikely to be affected whether it's a cold day, a warm day, or even a really hot day. As you go on over that time, the climate will start to have an effect. Hills can be hard to control workload on, especially if you've got a hill like this which starts off flat and then goes up here. So you could end up with a horse that has the same average speed the whole way up, or a horse that's gone very slow and then very fast, or very fast and very slow, and you'd see very different heart rate patterns, and those would be very hard to interpret because the horses would have actually done different work. So you could compare two horses that went together, but you would find it very hard possibly to compare one horse that's gone up here and then another that's gone up here the next day. All weather gallops are always really good for doing fitness testing, exercise testing, just because of consistency. So we've said we've got this number V140. What in reality does that look like? Well, here's some average values from some groups of horses that I've looked at over the years. Not surprisingly, riding school horses would be at a heart rate of around about 19 kilometers an hour. Interestingly, fit 3-day event horses up around 25. I should have done my calculator and worked out what that is in meters per minute for you. The British endurance team that won the silver medal in Compiègne in 2000, those horses were very similar on average to an endurance stable in the Gulf. Now, obviously those are average values, and when we look at the range, it's quite interesting. In this particular riding school, there's some very, very good horses, and some not so gifted. And again, within this big endurance stable, there were, again, some very good horses. That's a horse that can run really at around 27.5 kilometers an hour at a heart rate of 140. You'd easily be able to do a 100-mile race at that sort of intensity, 140 beats per minute. But interestingly, look at how high some of these elite 3-day event horses are as well. So very high fitness and aerobic capacity. Now, let's come back to a recording, and what I'm going to show you is how you would calculate that V140 if you had a recording like this. Now, within the sort of software that comes with most heart rate monitors, there's the ability to take averages of different parts. So what I would do in the Polar software is to put in a marker at the start and sort of end of the periods of exercise. Now, what I've done there, because that was a little overshoot there, I've ignored that because that's not really representative. So I've ignored that little bit there. I've try not to filter out too much of the data. Very hard to know which to take there. But what we can then do with the software is we can say, get it to tell us what are the average heart rates for each of those sessions or exercise sessions. So what that's telling me is what was the average in this period, what was the average in this period, and this period. And once I have those average speeds and average heart rates, I can do what every scientist loves to do, but it's not it's not just the realm of scientists. Anyone can use Excel and draw graphs. I can plot the heart rate against speed for those different pieces of work. Apologies, I think there's somebody flying over in a plane. Should be gone in a sec. Should have shut the doors after all. We're very near to, well, relatively near to Duxford, where I live as well. So we get a lot of planes over, the older ones that are really noisy and fly quite low. Okay, so we've got our nice straight line here because heart rate and speed should be related. And we can calculate our V140 from this. All we need to do is draw a line across at 140 and then drop down to see what speed that is. And that for this horse is 25 kilometers an hour. Now, if I did that again, that same test, and I did that sort of, I don't know, a month or two later, if the horse wasn't particularly fit here, but here was after 8 weeks of solo training, the great thing about that test is I don't have to go at exactly the same speeds as I went before. It doesn't matter. Because this relationship between heart rate and speed is linear, I don't have to produce exactly the same test at the same speeds. I should do the same times for each sort of, you know, like if it was 2 minutes here, 2 minutes here, 2 minutes here, it should be 2, 2, 2, 2 here. But it doesn't matter because these should all be on a nice straight line. And what we can see here is that the V140 for this horse has increased. It means that I can now go at 29 kilometers an hour with a heart rate of 140. Now, if we did that V140 measurement, say every couple of weeks, we could monitor a horse's response to training. So, for example, here's a horse that started off with a V140 of about sort of 13 kilometers an hour. And over the first sort of 6 weeks, we've got a nice increase, but then it's actually plateaued off, which tends to suggest we've had a good response here. Probably by here, we should have been changing the training again to get a further increase. Here's a pretty poor response because the horse is actually progressing relatively slowly. It's consistent, but I would have expected a sort of much steeper response. You know, the horse still isn't at a stable level of fitness even after 16 weeks of training. What's also useful is that if we are monitoring how our heart rate is changing with training, if it suddenly starts to go the other way, that could be due to something that's gone wrong. Could be due to lameness, could be due to an infection, respiratory problem, heart problem. If you saw this, this would be a really, especially if this was, you know, not perhaps the first one, you could say, oh, that might just be a bit of an oddity. I'll repeat it the next week. But if it's still down, that's an indication to possibly to talk to your vet about what might be going on. One of the other reasons this could be happening is because of overtraining, pushing your horse too hard. Your horse can't cope. Now, just to show you another example of excitement, because as I say, when we do try and do things at low heart rates, excitement can be an issue. This is a very recent recording that was shared with me by somebody riding at 5-star level, and you can see we've got the speed here, but look at this. So the speed's actually dropping. Look what's happening to the heart rate. This horse saw something that really excited it, up to sort of about 100, 155, 160. And again, look, a big jump up there. What's interesting about this horse is, I'll show you later. Now, so there we've talked about using heart rate measurement during exercise to characterize in what sort of state a horse is in, fitness, ability, health-wise. Now, probably a lot more people might be familiar with using heart rate recovery as an indicator of fitness. For me, the two go together. I want to know something like V140 or V200, doesn't really matter as long as it's reliably done. And I want to know your horse's heart rate recovery, because the harder and longer the exercise, the slower the recovery, the hotter the horse, the slower the recovery. So this is one of the reasons why we were talking about doing short tests, because we don't want the climate slowing down the horse's recovery if we're trying to use that as an indicator of fitness. There are ways sort of we can get around that. In a lot of horses, we can see 3 phases of recovery. The first is a very rapid phase that happens sort of in the first minute or so. We then see a sort of slower intermediate phase, and then we get the really slow phase once the horse is usually back in its stable. Now, if we can actually see this happening, if we look at real recordings, I can't believe it, that's another plane going over. There haven't been any for weeks. Must be because of lockdown being relaxed. What we can see here very nicely is that this is a polo pony that's done a warm-up and then played in 2 chukkers. And we can see that after the warm-up, the heart drops in that first minute very rapidly, and then we see the intermediate phase afterwards. That's dropped to about what sort of 45, 50 beats per minute very, very quickly. That horse hasn't been challenged. But look, after we do the first chukker, we can see the heart rate was up here just at the end about 160, and then drop really rapidly to about sort of 90. But look what happens after the horse has had a rest. We can see here the fast, intermediate and slow. This was the example from the previous one. We can see that here that this pony is being played much harder, much higher heart rate, much longer, plus it's already done a chukker. Look at the effect all of this has. We still get the fast drop, but it settles out at about 120 beats per minute. What do you interpret from this? This isn't about fitness. This is about saying this pony's done enough work for its fitness ability, and or it probably needs cooling as well because it's pretty hot. So just a simple trace like that without any speeding, I can tell there's a lot of information in there, and we can see the effect on a horse's recovery. Now here's some nice, simple, I hope, theoretical heart rate recoveries. So imagine if we did a 2-minute canter with our horse at a heart rate of 140, and then we measured heart rate at sort of 1 minute, 10 minutes, and 20 minutes. So here we've got him, this horse hasn't been particularly stressed. 1 minute, we're already down to a heart rate of 90. What happens if we increase the duration of exercise from 2 to 4 minutes? What would we expect that to do to the heart rate? Well, we're working at the same heart rate, but for longer, so we might get a slower recovery. So same speed, same intensity, but for a longer time should mean that we get a slower recovery. What happens if we keep the time the same, 2 minutes, but make the horse work harder? So a higher heart rate, but for the same time. Again, I'm sure you've already guessed it. It should slow the recovery. Now, sometimes this can be difficult and subtle to measure, but if you've really, significantly pushed your horse harder, then you will see these sort of effects of a slower recovery. So the problem is, the recovery isn't just a function of your horse's ability and fitness and health, it's also a factor of what you've actually done as well. So if you do longer or harder, or longer and harder, then that will affect your horse's recovery. So if you're trying to use recovery, a test, and look at recovery as an indicator of your horse's fitness, you need to make sure you're doing the same test each time. Otherwise, you're going to get meaningless answers. So if we do a standardized exercise test, when should we take the recovery heart rate? Well, there's a really good clue in this one. And again, I've come back to this same trace because there's so much information in this one. We can see that we get the really nice rapid drop here after we finish exercise. This horse doesn't work very hard, but what we see in that as the horse starts walking is the heart rate's going up and down. Now, if you didn't have a recording heart rate monitor and you were just looking at something on your watch, you could look at your, look at your watch there and say, okay, I'm going to take a 5-minute recovery, and you look there and we've got, oh, that's really good news. I've got, what's my heart rate there? Oh, brilliant, 70. Yeah, very fit. You could look a couple of minutes or a minute later and see, oh my God, it's 110. Oh, my horse is really unfit. I'm going to have to panic. So that's the problem of not having a heart rate monitor where you can see the whole trace. And of course, this is why we often say we want to take the recovery heart rate very close to the end of exercise, normally sort of 1 minute or 1 to 2 minutes, 3 minutes at a push, because that is when it's most reliable. We don't want to try and take it here at 25 seconds because if we're 5 seconds out, we could be at sort of 135 or we could be at 100. So we want a period where it started to really sort of slow down, sort of like say here, but really what we're looking for is to take it sort of 1 or 2 minutes after we've finished the piece of work. So, general rules for using recovery heart rate. To compare tests done at different times, the test must be the same, and that means thinking about what surface you're on, the speed, the distance, speed again. I didn't think it was that important, apparently it is. Do the same thing after exercise. For example, you could pull up over 100 meters and then walk 100 meters, or you could pull up over 100 meters and stop. But it's important that you do the same thing each time, because again, what you do in that 1 to 2 minutes when you finish as you're pulling up from exercise will affect the recovery heart rate. Measure it close to the end of exercise. Another good rule is if your horse's heart rate's above 100 at 1 to 2 minutes of recovery, your horse has probably done enough work, whatever you're doing, whether it's training. If it's in competition, you've pushed your horse pretty hard. And again, you know, if it's up around 110, 120, not coming down, then you need to probably think about cooling. If your horse is ataxic, you need to get it moving and walking and being cooled as well. Here's a really simple test. This is 1 minute recovery heart rate in fit endurance horses after they had done 54 kilometers as a group. And look, we can see here, we've got some horses, 1 minute, just below sort of about what, 65, 70, 69. We've got others up around 90. This doesn't mean these are better horses. It could be that these are same ability but fitter, or if they were all as fit, we would say these were the higher ability horses. But again, it's slightly complicated because the recovery heart rate is a combination of genetic ability, fitness, health, intensity, duration, climate. It's a snapshot, and it's reflection on exactly what work you've done on what surface in what conditions with your horse. Now, this is why we talk about testing horses as a group. If we test them as a group, we can see how hard they're all working. If we look at their recovery heart rates, we can see how quickly they recover. And those two pieces of information really allow you to get a phenomenal insight into the horse's state in terms of, let's say, if they were going to compete. If I was picking horses for a competition next week, I had to pick 4. I'd probably pick these 4, provided all other things like lameness were considered. So I'd probably pick those if it was for a week, as I say, a week away. We've used this as an example of a good trace. Here's an example of a bad trace. This can happen when you don't get a recording at the start. Usually that's because you haven't wetted the horse's coat down before you put the electrodes in place, or you haven't tightened your girth up enough. We sometimes get them. Again, some riders do loosen off their girths when they've finished a piece of work. And again, that can be a reason why you lose the signal there. Sometimes the electrodes can move. It doesn't look like it here because the signal comes back afterwards. And it wasn't particularly the fastest speed. So generally, this is quite a good recording. This is a terrible recording. These are the ones you hate to see when they come back because sometimes you can't tell that it's going wrong. You should get a clue if your horse's heart rate is constantly 120. Excuse me. That's a warning sign that something's not right. One of the important things when you're putting a heart rate monitor on is where you place the electrodes. You want them somewhere where they're not going to move a lot, because if you do get movement between the electrode and the skin, that's going to give you a false signal. But if you put them too close together, you're going to get a smaller signal going into your heart rate monitor. The reason that's important is because during exercise, we get a lot of electrical noise, and that noise comes from the muscles. The muscles are generating small electric currents, which will be picked up on an heart rate monitor ECG. And you will also get movement of cables, which can cause you to have this noise. The problem is, if your signal is above that noise, you'll get a beep registered. If that signal is swamped by this noise, then the heart rate monitor may not be able to pick up a signal. Obtaining good recordings. Well, if it's really important, then brushing the coat. It's better on a clipped horse than, of course, on a horse with really long coat. Cleaning the coat to remove dirt and grease. Checking your batteries. Very common user error. Cleaning with ethanol, not to remove grease. That's more if you're trying to stick on ECG electrodes, I'd say. Wide electrode placement. Don't have the electrodes too close together. Ensuring that leads don't flap around. Ensuring that the connectors are clean, not corroded. You see a lot of that. Reducing the lead movement if necessary by taping them down. Wetting the coat and using electrode gels are really, if you don't get good signals. Okay, so what we're going to finish up with is looking at some traces of horses in competition. And this is because we can actually read quite a lot. And here I don't even need the speed. In fact, when we did this in 1994, this was when Mark Todd won badminton. Was it Halton Point? I was fortunate enough to have a heart rate monitor on his horse. In fact, you might just be able to, you can just sort of see it on his hand next to his stopwatch. Now, what's interesting about this trace compared to another less experienced rider, this rider went basically, their speed varied up and down throughout the course, and there was a lot of variation in speed. When we watched the video back, they pulled the horse back really, hard, coming into fences. They jumped the fence and then they kicked on afterwards. And so there was a lot of change in pace. And you can see the effect of this on the heart rate. When we look at what Mark Todd does, he kind of sets off and he builds throughout the cross country, just pushing a little bit harder, a little bit faster as he's going round. Completely in control, and much less variation in heart rate because he maintains, when you watch him, he maintains a much smoother pace through the jump complexes. Now, here's a trace that I was shared very recently, and I've got permission to use from, this is a 5-star cross-country course, and there's lots of interesting features we can see in here. The first thing is, as this horse is walking from the stables, he's quite relaxed. He's here in the stable, really relaxed, starts walking, really relaxed, starts to see the other horses. He's still walking, but look, heart rate's going up. This is not related to effort. This is excitement, anticipation. We can see here, warm-up heart rates, pretty high. Not bad for the heart rates that are going to be attained during the cross country. It's good to get splenic contraction. We need a relatively high heart rate to get the spleen to empty, to maximize usage of oxygen on the cross country. I'd probably say we've got reasonably good heart rate recovery here. We're back down within a couple of minutes to sort of 70 beats per minute. The horse is sort of pretty much just standing, moving very slowly here. Then we've got quite a long period before the start of the cross country. I'd like to ideally see this last sort of canter or jump in a little bit closer to the start of the cross country. Now that can depend on individual horses' temperaments. Reason though I want to see it a little bit closer is I want to see the number of red cells still high in the circulation, so that we've still got that splenic contraction. Because although the spleen empties here, if you don't do anything, the red cells go back into the spleen. Now, they won't have all gone back in, but a lot will by this time. And then the cross country itself, really interesting features here. What we can see is that heart rate is pretty high from the start and stays pretty high for most of the cross country. It's also tending to creep upwards. And at the same time, what's interesting is the average speed is tending to come down. Now, there's also a lot of variation in speed, and I would say that this horse is not possibly being ridden in the optimal strategy. Now, I don't know the horse that well. It could be that there are reasons why the horse has to be ridden like that, but if we were taking this as an example, I would be wanting to say to the rider, not starting off quite so fast here at the start, if that's possible, maybe not. Trying to maintain more of a sort of an average speed without this drop off to the end. When you see this drop off in speed sort of throughout across country, you tend to worry about horses starting to become fatigued, if they can't keep that up. And that certainly fits with a high heart rate and a high speed at the start. Again, heart rate recovery here, I don't know. It looks to me that this is a pretty slow recovery. So I might be a little bit concerned. I'd like some more information here, because that kind of fits with what we're seeing here, which is the horse has been, pretty hard ride, slightly tiring in because of the speed. this very up and down. If you want to tire a horse, a variable speed is the best way to do it at a very high intensity. If you want to ruin your chances of running the marathon, keep changing your pace. This is the same horse actually, but in training. And again, what's interesting here is we can see this sort of effect of the heart rate recovery, not so much on the first two, but on this one, certainly a slightly slower recovery on this one. Not such a good recording there. We've lost, possibly lost the electrode placement there. But we can see this horse gets a little bit excited way before he knows that he's coming to do some work. Not unusual, but having done a little piece of work, then we see he's pretty relaxed. He's very comfortable while he's walking. And generally, we've got some pretty good heart rate recoveries here. Good level of work, getting up to sort of pretty high heart rates, 216. Again, we would have to take this in the context of the whole training program rather than making comments just on this isolated trace. Here's another one. This horse is having to vary its pace quite dramatically. The red is the blue, and it'll become apparent when I show you the next slide. Reasonably high heart rates again. This was the test event for the Hong Kong Beijing Olympics, and the reason why the heart rates were so high was because of the fact that we had a very twisty track, and there was a lot of changes in pace that needed to be used because it was a very small space that was available. We can move from eventing and look at show jumping. This is a fairly professional level show jumper, a training session. We can see the blue, the speed here. So we've got some periods of activity, canter here, and jumping, and some periods of standing and some periods of walking. And we can see getting up to the sort of heart rates we would expect, up around the 170 to the 180 level. If we look, so that horse is not being overworked for whatever it's jumping. It's recovering quite quickly. We can see these heart rates dropping down to sort of around the 70s, 80s. Slightly slower recovery after the last one here. So you would say that's that horse has done a reasonable session, hasn't been overworked, possibly could do another round of jumps if that was required. 2-minute recovery heart rate, 93 beats per minute. That's okay. If it was my horse, I'd be thinking about calling it a day after that amount of work. That's a sort of, what are we looking at here from the start? 10 minutes to 50. That's a 45-minute session. You know, that's not a bad session probably for most show jumpers. Here's another example. This is a very old one, but it's one I love to show because for an endurance horse, this would be the thing that you would really want to avoid doing. Because first of all, we have quite a lot of variation in heart rate, going up to almost 200 and back to sort of probably 80. That sort of variation in effort is incredibly tiring. Whether this is variation in speed on the flat, or whether it's variation in effort by maintaining a constant speed over hilly terrain, this is not what you want to be doing. Because every time we go up here in this sort of about above 150, we're pushing the horse into using glycogen. And glycogen is the energy source that's always limiting in endurance. This is the way to fatigue a horse, is to ride it with this sort of pattern. So if you are riding constant speed on a flat surface and you've got a heart rate monitor, your heart rate shouldn't change. If you are riding to your heart rate monitor over hilly terrain, you should be slowing down to maintain the same heart rate. You should be speeding up as you go down slight inclines because the heart rate will drop. So you should be riding to effort, not to speed. And the same goes really for hilly cross-country courses. doesn't really apply in racing, may apply possibly in carriage driving in some circumstances. This is one of my favorite examples of why you should be using heart rate monitors for training. This is a study that was done about almost 18 years ago from Australia. They looked at the heart rates of horses being prepared for a 3-star competition. And then they measured what the heart rates were during the competition. And they found the average highest heart rate these horses were reaching in their training was 150 beats per minute. But the average peak during competition for the same horses was 195. So what that tells us is no way are the majority of these horses fit to do that type of work. And when they looked at the type of work they were doing, only one person here was doing sort of proper fitness work on gallops. Some people were cantering in paddocks on the beach. Some were just doing swimming. So this is a horse that's ready to run at that level. None of the rest of these horses really are. Possibly this one at 180, but really these horses here are definitely not fit to be competing at that level. And lack of fitness means increased risk of injury, poor performance.